lesson with complex numbers. But, so we have to remember, we have x equals negative b plus or minus the square root, b squared minus 4ac all over 2a. So for this problem, a is 2, b is negative 7, and c is negative 15. So I have x equals, I'm going to put 7 plus or minus the square root of 7, negative 7 squared is what?
49.
Positive 49. Minus 4 times a is 2, times c is negative 15, all over 4, because I have 2 times a. So then I have negative 8 times a negative 15. What's negative 8 times 15?
120.
What is it?
120.
120. So I have 49 plus 120, which is the square root of 169, which is what? 13.
I actually do that.
So you have 7 plus or minus 13, all divided by 4. 7 plus 13 is 20 over 4. And 7 minus 13 is negative 6 over 4. And then you can simplify this down to 5. And you can simplify this down to negative 3 over 2. And those are your two answers.
Yay.
Good enough?
I did it right.
Because we're leaving this today and we're going to go on to complex numbers. So, I think somebody in here had asked me what you do when you get a negative under the square root. That's when you get a complex number, an imaginary number. So let's go ahead and grab notes for 4.8. What? Remember, your test over all of this is on Friday. I have a new lesson today and then one example tomorrow. Well, tomorrow's example might turn into 2 or 3, but and then we'll concept quiz on Wednesday, go over it on Thursday, test on Friday. Okay. So, when you have the square root of 25, we know what the square root of 25 is, because 5 times 5 is 25. But what if I had the square root of negative 25? Can you take the square, can you find two numbers that are the same that multiply to give you negative 25?
No.
No, the only way to get negative 25 is, well, negative 25 and 1 or whatever, but 5 and negative 5. 5 and negative 5 are not the same number. So when you have a negative underneath the radical, it becomes imaginary. So what I want you to write down, I want you to put a big star, and I want you to put the square root of negative 1 equals I. I stands for imaginary, because imaginary numbers are still important. They still tell us something about our graph when we use them to graph. But today we're just going to look at adding, subtracting, and multiplying complex numbers, which are imaginary numbers.
Wait, does our I have to be curvy? No.
I always do, but you can do what you want. Then we have I squared. So if we square our I, we get I squared. If we square a square root of negative 1, what do you get? What happens to the squared? Or what happens to the square root and the squared?
What? Oh, you get a negative.
Negative what?
Number.
What number?
I don't know.
Negative 1. Okay? So these two pieces of information are really important for what we're doing today. So I want you to put a big star next to it because you're going to need to refer back to it. So now that you know that I is the square root of negative 1, if I want to simplify the square root of negative 25, I'm going to break that down to be negative 1 times 25. So I'm just going to rewrite this as negative 1 times 25. And I can take the square root of each piece. We know the square root of 25 is what?
5.
5. And we know the square root of negative 1 is I. So this becomes 5I.
Wow.
So we're going to do a couple more of these, just simplifying the radical.
Leave it at 5I.
Yep.
Oh.
just simplifying the radical. We're going to start with that, and then we'll move on to our complex numbers. So if I give you the square root of negative 18, 18 is not a perfect square, so I just have to simplify the radical. What two numbers multiply to give you 18?
9, 2.
9 and 2. Which one's the perfect square?
9.
Okay, so what I'm doing is I am, and you don't have to write this next step out every time, but what I'm doing is I'm breaking this up to a negative 1 times a 9 times a 2. And I'm going to do the square root of everything I can underneath the radical. So this number here, negative 1 times 9 times 2, is negative 18. But now I'm just looking at what parts can I take the square root of. What's the square root of negative 1? I. What's the square root of 9?
3.
What's the square root of 2?
2.
You can't do it. So you just leave it in the house. So that would be that answer. So you can always take the negative out by taking an I out. And then you look at breaking down that number to be two numbers that one of them is a perfect square.
It's going to get harder, isn't it?
So, well, yes. So why don't you guys do this? The square root of, I'll give you an easy one, negative 12 on your own paper. See, I told you. And then there's 2 letters sitting on my desk. Will you put that down to outgoing mail? Thanks.
These ones?
Yeah. Thank you.
Yep.
Okay, 3 things to break 12 down. I'm going to get us started. Negative 1. And then what are our 2 numbers that multiply to be 12?
12.
4 and 3. Okay? What's the square root of negative 1? I. What's the square root of 4? And can you take the square root of 3?
No.
No, so that stays in the house.
So is there such thing as using like the wrong combination?
No, no, because there's only one simplified form, so sometimes you could use, there's different combinations, and you may have to do it again.
Oh.
You know what I mean? Like
Yeah.
72 is one I usually give you, and it's, everybody says 8 and 9, but then 8 has a perfect square in it. So just make sure there's no perfect square left in the house when you're done. Okay? Are we good with simplifying? I actually forgot this was part of it. So let's move on to complex numbers, what we're really doing today. The complex numbers looks like this. A plus BI. Where A is a real number, 4, 5, 6, 7, 8, 9, 10, 11, 12, just a real number. And BI is your imaginary number.
BI is one
So
number.
it's a combination, just like we wrote 5I. It's a combination of a real number and an imaginary number. So you have a real part and a complex number. That's what makes it so complex. You have a real part and you have an imaginary part. When we go to do things like add, subtract, and multiply these complex numbers, treat the I like an X, and everything's the same. All the rules are the same. So let's start with adding complex numbers. When you have something like this, 4 minus 3I plus 5 plus 8I. If we think of, we're just adding, we're not multiplying. If we think of the I part just like an X, if I would have had 4 minus 3x plus 5 plus 8x, you guys would tell me to drop the parentheses and just combine like terms, right?
Yeah.
Like put the 4 and the 5 together and the negative 3x and the 8x together. That's exactly what you're doing here. You're just using the I. So you're going to take, because it's plus, I don't need the parentheses, but I have 4 plus 5 is 9. And negative 3i plus an 8i is plus 5i. And that's your answer. Another thing you need to note is you want to always write the real part first and the imaginary part second when you write. Like you wouldn't write this 5i plus 9. I probably won't take off on your test if you did that, but it's not mathematically correct. Okay? So now let's look and see what we do when we subtract. There's just one extra step. So if I have 5 minus 3i minus 4 minus 6i. What does your gut tell you need to do with that minus sign here?
Distribute it.
We need to distribute. So we're going to take and distribute in here and change our signs. So this becomes a minus 4 plus 6i. And then you're just going to do what you just did when you added. You're just going to think of no parentheses and combine like terms. So you'd go 5 minus 4 is 1.
Plus 3.
Negative 3i plus 6i is going to be plus 3i. How easy is adding and subtracting?
Pretty easy.
Pretty good? Okay, so let's math it up a little bit. Are we ready?
No.
So adding and subtracting, what you need to know is you combine like terms, and when you're subtracting, you have to distribute your negative in. Okay? So now we need to go back to what happens if I have x times x? What does that become?
X squared.
X squared. So what do you think happens when you have I times I? I squared. What does I squared equal? Negative 1. Negative 1. So we're going to have to, once we find any I squareds with the multiplication stuff here in a minute, we're going to have to change it to a negative 1. So we'll start off small. And we'll do something like this. 3i, so we just have an imaginary number, times negative 5 plus 2i. So we're going to take and just distribute our 3i in and multiply just like this was a 3x and this is a 2x. So when I multiply 3i in here, I get a negative 15i plus what? 6i squared. Okay? Make sure you have the multiplication right. Everybody good with that? Just distribute it. Then what you have to do is every time you see an I squared, you have to change that to negative 1 because remember that thing I had you put a big star by,
Crazy.
I squared is equal to negative 1. So this becomes 6 times negative 1, and what's 6 times negative 1?
Negative 6.
Negative 6. So now I have negative 15i minus 6. There's no more I squared. Now, I just a minute ago told you what has to be written first in this answer. The real number. So I'm going to rearrange this to be negative 6 minus 15i. And that's your answer. I'll be honest, today, like, if for some reason that is tripping you up, I'd be happy if you end here today, but you need to get to that point. Easy enough? Okay, now let's math it up a little bit more.
Division.
No, we're going to divide tomorrow.
Oh,
Which division is fake. It's really just multiplication. So let's do this where we have to use either FOIL or the box method. So I have 4 plus 3i times negative 1 minus 2i. So do whatever method you want. I'm going to do FOIL. So I have 4 times the negative 1 is negative 4. Then I have 4 times the negative 2i is negative 8i. And then 3 times the negative 1 is minus 3i. And then 3i times negative 2i is negative 6i squared.
So plus 6.
Okay, so we first need to combine like terms before we can do anything. But is everybody good with these numbers that we have?
Well,
We all agree? Okay, so on my inside here, I have these two that are like terms. So I'm going to have negative 4 minus 11i and then minus 6i squared. And then what does I squared equal?
negative.
Negative 1. So I really have a 6 times a negative 1 here, which a negative 6 times a negative 1 gives you a positive 6. And then what can you combine the positive 6 with?
4.
The negative 4. So I have a 2 minus 11i.
Don't do
Pretty easy.
Yeah.
I'm going to give you guys one to do on your own. And then I may let you go with your homework. So we have 5 minus 7i times a
And you combine the two
2
middle terms.
minus 3i.
You combine the negative 8 and
These two. Just add it together. Okay, so do this next one. Okay, so I got a 10, a negative 15i, negative 14i, and positive 21i squared. Do you guys agree?
Yes.
Okay, so I need to combine like terms here. These two both have an I, so that gives me 10 minus 29i plus 21i squared. What does the I squared equal? Negative 1. So what does this positive 21 become? Negative 21, which can combine with the 10. So that gives me a negative 11 minus 29i. We good with that?
Yes.
Okay, I just have a handful of problems today. Well, this stuff didn't take very long. This stuff takes the longest, and I don't have very many of these. So we're going to go over this in class because you're going to have 30 minutes to work on it. But it's page 253, 8 through 10, 18 to 26, 53, and 54. I'm going to check this off in class and go over today.
28. Right? Right?